Good evening. Welcome to the Hampton Bays High School's 8th Annual Research and Science Symposium and 2nd Annual Virtual Symposium. My name is Lars Clemenson, and I'm the Superintendent of the Hampton Bays School District. We're so glad to have you as our guest tonight, and I'm sure that you're going to leave tonight a little bit smarter and, more importantly, more inspired about the potential of our young researchers, the potential of our future, what that means in our world today. There's a beauty to remote and virtual gatherings after such a challenging year as a community and a global society. We have folks watching us from around the world tonight and who will continue to connect to tonight's symposium both in real time and in the hours and days to come. And so we're embracing this reality and bringing to you just some of the very best that Hampton Bays has to offer. As we begin, I'd like to take a moment on behalf of the Hampton Bays Board of Education and the entire school district to wish each of you well. We hope that as you watch tonight's symposium, you're healthy and that you're staying physically, mentally, and emotionally connected. That's the priority that we face and value every single day for all of our staff, students, and faculty. In so many important ways, the Hampton Bays Schools has committed to continuing to move forward since that first day of school closure last March 2020. I continually am remarkably impressed by the resolve of our great community. Teachers have dug in like never before to teach, to connect, and to innovate. Families adapt on a dime, with so much being asked of each of you at such a difficult time in our world. Now more than ever, we hope that you consider the school partners in addressing needs that you may have. And most importantly, we're wowed by our students, the skills they've developed over this time, the perseverance they've shown, and their desire and commitment to stay connected. Their creativity, their spirit, and their work ethic has allowed us to navigate this year, opening the valve day by day as we approach our back to normal type experience. The science research program is the most challenging course of study that our students in Hampton Bays can take. The work is done over a 4-year period and is done individually in small groups with a mentor and a tremendous amount of independent study. Under the very best conditions, this is a rigorous and challenging 4-year program. Throw in a global pandemic and the road becomes that much more challenging, and the product that you'll experience tonight becomes that much more wonderful. As you'll see tonight, these young researchers have risen and surpassed expectation. What you'll experience reinforces for me my sense of security, my sense of optimism. The challenges we face today will pass, and the worries that we will have, or that we have, at some point will be in the rearview mirror. While we would, of course, prefer for you to be together with us in the high school auditorium tonight, we'll connect virtually and we'll enjoy the Science Symposium in the comfort and familiarity, with the comfort and familiarity of our greatest asset in the school district, our students. I'd like to acknowledge some special guests watching with us this evening who have been longtime supporters of our science research program. Board of Education members President Kevin Springer, Vice President Rich Joslin, Trustees Dot Capuano, Ann Colhane, and Liz Scully. New York State Assemblyman Fred Thiel, Suffolk County Legislator Bridget Fleming, and members of the Southampton Town Government, Southampton Town Supervisor Jay Schneiderman, and Town Board members Rick Martell, Julie Lofsted, Tommy John Scavone, and John Bouvier. I'd also like to acknowledge the mentors in the field and from around the nation who have willingly committed to our student researchers. You'll hear from our great students tonight presenting the culmination of their work over 4 years. Perhaps in 8th grade, they knew they'd end up here with this research. However, I think that if you had a conversation with each of them, they'd each tell you that their work took them on a journey of twists and turns. On Thursday, we'll invite you back to see the work of our underclass researchers whose work and twists and turns are still underway. I'd like to credit the university and the high school program at the University of Albany and its directors who are watching from the Capital Region tonight. We value this tremendous partnership with you and appreciate your commitment to us, to our kids, your willingness to help us innovate, and especially tonight in supporting our continued virtual symposium series. I want to offer a special thanks to Dr. Stephanie Forsberg for her coordination of this program, all the members of the science department from kindergarten through 12th grade, and the faculty and staff who without their support this would not be possible. Our students are ready to introduce you not only to their research question, but to the work that has consumed their thoughts, your dinner time conversations, and those between the hallway, between the classroom, between the summertime, between the school year, chats about what invigorates them and what makes them excited. At a time when the future can feel uncertain, these senior students represent the future. You'll leave tonight feeling more certain, more confident, more hopeful for what's to come in the days ahead. Thank you all for being with us. Enjoy your time at the virtual Hampton Bays High School. You're all always most welcome here, whether we're in person or connecting virtually as we are tonight. At this point, I'd like to introduce to you Dr. Stephanie Forsberg.
Thank you, Mr. Clemenson. Good evening and welcome to our 8th annual Science Research Symposium and the second year in our virtual setting. First and foremost, I would like to thank our Hampton Bays Board of Education for bringing this program to our students and for their support of our continued affiliation with the University at Albany through the University and the High School program. Also, our program is grateful for our administrators, our faculty, mentors at both the college and university levels, and for you watching tonight from Hampton Bays, across the state, across the nation, or even around the globe. Please tell us in the feed below where you're joining us from tonight. By watching tonight, you're supporting these amazing students despite us needing to keep our physical distance as we are still battling this global pandemic. To pull off a virtual symposium requires a lot of technology. And tonight I need to start by thanking Mr. Eric Ferraro for his support in that arena. Thank you all. We know that this year has been challenging to say the least, but I'm going to focus tonight on our senior class. These researchers are going to give you amazing examples that have resulted from our changed world. These students that you're about to hear from have embraced our changed circumstances and are graduating from the science research program with a toolbox that even I had never quite imagined. We have covered, and these students have mastered virtual meeting etiquette and professionalism, how to present to a variety of audiences remotely on multiple platforms, how to prepare an interview remotely for colleges, universities, and scholarship interviews, and how to take their science knowledge and share it with those around the world. Every single one of these students that you hear from tonight will present and will later graduate and make Hampton Bays extremely proud as they bring their Hampton Bays toolbox with them to impress and wow their professors, colleagues, and through all of their future career paths. This graduating class is a team, a family that I couldn't be prouder of how they have supported each other these past 4 years. I am always impressed with what they are learning on their own. In preparing for tonight's symposium, I even was taught a lesson from one of our seniors. Tara Lowther pulled me aside and helped me in editing URL links to properly convert into a Zoom meeting. Phrases that I never thought I imagined would come out of my mouth as a science research professor or instructor. I am so grateful for each and every one of these students and to be part of this educational team, grateful every day. The pandemic and the changes we have endured this year have only made our team stronger, and I hope that you'll be able to sit back, enjoy the presentations of the science research class of 2021. Feel free as the night goes on to type your questions into the comment feed below. This is going to be monitored and we will be able to ask your questions directly to the students at the end of the presentations. Additionally, if we do not get to ask your questions live due to time constraints, our students will be going back into this comment feed and thread to answer your questions and address any dialogue there. Thank you again. And kicking off our first talk this evening will be our senior, David Katina, who has been investigating the medical applications of 3D printing with his mentor, Dr. Murat Gubern from the New Jersey Institute of Technology.
Hi, my name is David Katina, and I will be presenting my research on the medical applications of 3D printing. When I first heard of the science research program back in 8th grade, I thought it was a great option. There was no reason I shouldn't do this. Once I said to myself that I was definitely going to be a part of it, I began to think about what topic I wanted to look into. And I first started with construction materials, and I immediately started to look into self-healing concrete. This is a concrete with a very specific bacteria that would notice a crack. It would notice the air, and it would fill that crack automatically. Very interesting part. But I decided that I didn't want to spend 4 years researching it. So I moved on to nanotechnology, which deals with very small particles, as you can imagine, 0 to 100 nanometers. To put that in perspective, the width of one piece of newspaper, very thin side, is 100,000 nanometers. So you're dealing with very small particles there. I also decided that I didn't want to spend 4 years on that. So then I happened upon 3D printing, which, as you probably already guessed, that's what I continued my 4 years of research on. So in this program, we're instructed to look for a mentor. It's not mandatory, but it's the best option too. So naturally, I started to look for mentors in the 3D printing field. And I emailed around 5 to 7 mentors and either received no response or politely declining, said they were busy. That's all right. Although towards the 5th or 6th no response, I started to lose hope for 3D printing. So then I went to look for mentors in the nanotechnology field. Almost changed my topic completely back to nanotechnology. I emailed around 2 to 3 and received no response. One that seemed promising, but luckily I kept looking for mentors in the 3D printing field, and I happened upon Dr. Murat Gubern. I established that mentorship at the end of my sophomore year, and that was much later than all of my classmates, so we were very happy when I got it. It was a big deal. So Dr. Murat Gubern works at the New Jersey Institute of Technology. He's a chemical engineering professor, and he runs the Instructive Biomaterials and Additive Manufacturing Laboratory. This picture on the left is myself and Dr. Gubern in his office. We were going over what we could do for my research for the remainder of my time in the program. This picture on the right is me in a workshop of his where he teaches his students, and those are 3D printers that his students would use in their class. Getting back to 3D printing a little bit, there are many major applications that are growing every day in this field. And I'm just going to talk about a few of them today. So the first one I'll talk about is the 3D printing of anatomical models. Now, this is a very important one because anatomical models used to be very expensive and they used to take a lot of time to make. But now, thanks to 3D printing, patient-specific anatomical models can be made in a very short amount of time, and they're very cost-effective. As you can see in this photo here, the diagram on the left, it would be much easier to find a problem in that person's brain rather than the diagram on the right, which is a 2D scan, and then to find a problem in that picture. Another major application is the printing of prosthetics. As you can see in this picture on the left here, this is an exoprosthetic leg, and the developer was actually able to make it with titanium. And that is why it is able to stay together and not break, even though it looks so thin. That titanium is strong enough that it doesn't break when the person is walking on it. The third application that I'll discuss is the printing of surgical tools. As you can see on the right, this specific surgical tool would be used to look behind an organ or another piece of tissue inside a person when a surgeon is performing surgery on them, eliminating the need for that surgeon to make another incision. So it's helping the surgeon while cutting down the surgical time, which is a great thing. Science research has taught me a lot based on my topic especially, but I think the most important thing that we take away from science research are the life lessons that we learn, such as public speaking. My classmates and I, we've all learned to be much better public speakers than we were. We're not as nervous as we once were. We have more confidence when we speak. Another major thing that we've learned is time management. I did not manage my time so well at the beginning of high school or in middle school especially. But now is when I realize how important time management is, as well as preparedness. Say we're not prepared for a middle school class, that's not a big deal. Even high school, sometimes it's not a big deal. But if we're not prepared for a college class or a job interview, that could ruin our chances for the next couple weeks. Excuse me. That might take away your whole opportunity to get that job, especially if you really want that job. That'd just be a really bad thing for you. And one of the last skills that I learned in science research would be when to be professional in the proper settings. Say with these two pictures here. On the left, Dr. Gubern and I are going through 3D printed models that he has made. And that's the time you have to be courteous and listen and very diligent. And on the right, we're having lunch. That's the time you can be more casual and light and more fun. The program has also led me to my college because I will be going to the New Jersey Institute of Technology this September, and I'll be studying in chemical engineering. So not only has the program led me to my college, it's also led me to my major in college. I'm very thankful to Dr. F. She has helped me. She has helped all of us along the way. And this has just been a great experience. Thank you.
Presentation will be by Sophia Lowther. You may recognize Sophia as being part of our 11th grade cohort. Sophia is actually graduating early this year, so that is why she's joining us with the seniors. Sophia has been researching lamniopathy with her mentor, Dr. Howard Warman from Columbia University.
Good evening, everyone, and thank you so much for joining us in our second ever Virtual Science Research Symposium. My name is Sophia Lowther, and I will be presenting my research on laminopathies. Coming into science research program as a freshman, I had no idea what I wanted to do. The possibilities were endless, and so was my curiosity. I went from reading about exploration on Mars to the evolution of the human foot. However, after reading about Huntington-Gilford-Progeria syndrome, I realized how interested I was in the topic. There was not enough answers to the never-ending questions my mind had managed to unravel. I knew that Huntington-Gilford-Progeria syndrome was the topic I wanted to dedicate my high school career to. In my sophomore year of high school, I established a mentorship at Columbia University with Dr. Werman, who had a lifetime goal of finding treatments for laminopathies. Laminopathies are a group of rare genetic disorders caused by mutations in genes encoding proteins of the neurolamina. Some diseases that are laminopathies are Emery-Dreifuss muscular dystrophy, dilated cardiomyopathy, limbo-girdle muscular dystrophy, and congenital muscular dystrophy, as displayed in the graph shown. Emery-Dreifuss is a genetic and degenerative disorder that causes muscle weaknesses, cardiac defects, and dilated cardiomyopathy. Emery-Dreifuss is caused by the mutations in the genes EMD, LMNA, SYNE1, SYNE2, LUMA, and FHLI. LMNA and EMD are the most widely studied genes related to Emery-Dreifuss. Imarin is encoded by EMD, and it is a protein embedded in the nuclear envelope. It binds to other proteins and affects cell structures as well as cell signaling. The LMNA gene provides the body with instructions on how to make lamins, and two of the major proteins this gene instructs are lamin A and lamin C. HBHS is caused by a single letter misspelling in a gene on chromosome 1 that codes for lamin A, and this is a spontaneous mutation. Lamin A is a key component of the membrane surrounding the cell's nucleus. The abnormal lamin A protein produced in HBHS is called progerin. HBHS is an abbreviation for Huntington-Gilford-Progeria syndrome. Progerin induces earlier cellular synthesis that is associated with increased DNA damage signaling. Huntington-Gilford-Progeria syndrome is when an individual has a rapid appearance of aging from the beginning of childhood. All children with progeria develop severe progressive heart disease or atherosclerosis, which is a disease of the arteries. They also have a low bone density, lose their hair, and ability to have body fat, and do not develop as a healthy child would. As a child with progeria, At 17 years old, you may only weigh 50 pounds. These children often only live up to be 13 years old. Dr. Werman and I used mouse models to mimic the human mutations of Huntington-Gilford-Paget syndrome and Emery-Dreifuss muscular dystrophy. The mice were generated by the recombination method. The mice were fed a standard chow diet and were housed 5 per cage, as well as bred after being generated with mutations in order to have enough mice to do experiments with. The LMNA H22P/H22P mice was created to mimic the Emery-Dreifuss disorder. The pictures shown are of a 17-year-old girl. The individual's hands had a molted cutaneous pigmentation, nail dystrophy, and several short fingers, including the index finger on the left hand. Radiographs of the feet indicated abnormal bone resorption or deposition. The individual had similar skin, bone, and fat abnormalities that can occur in HGPS. However, the individual we described was affected to a much lesser extent than children with HGPS. The LMNA R648 mice models were created to mimic the girl's condition. These diagrams represent bone lesions in LMNA L648R/L648R mice, as well as control mice. These images of the L648R/L648R mice show 3 parts of a jawbone, as you can see marked with a green star. Failure of the zygomatic structure to close is shown where the arrow on the diagram points. Although we never got a CT scan of the 17-year-old girl's head, she has a small jaw and head circumference. These are mice with mutant lamin A CG allele, where the pre-lamin A does not get processed to lamin A. The homozygous mice in the pictures do not show as well as compared to the control mice. This is most likely occurring because they cannot eat due to jaw defects. In order to help them gain more weight, their teeth were shaved down. What is killing these mice may not be something systematic, but instead the jaw defects that prevent them from eating. These mice are not as sick as the HGPS mice, which reveals that there is something different between the full-length prelaminate and the truncated laminae. HGPS mice get similar bone defects, but also get vascular involvement, which may contribute to their death, as well as other factors we may not know about. Dr. Werman provided me with cutting-edge data and volunteered so much of his time to help me with my research. Working with him was the highlight of my high school year, as well as a great opportunity that I am grateful for. My mentorship was not the only experience I gained from the science research program. I also had the opportunity to help seed clams with my peers in protected areas of the Shinnecock Bay, and I was invited to the Spark Challenge of Peconic Bay Medical Center, where I was selected to visit various departments of the hospital. I remember coming into high school as a scared, naive, scatterbrained freshman, but it was Hampton-based science research program that helped open many doors for me, where I discovered the path I wanted to take after high school, as well as grow as an individual. With the confidence I acquired, I took up the challenge of graduating high school a year early, as well as completing a year of college at Suffolk County Community College. I plan to attend Adelphi University after high school, where I will be going to receive my bachelor's degree in neuroscience. Afterwards, I plan to go to medical school, where I can pursue my goal of becoming a physician. I know exactly what I want to do with my future, and I am not going to let anything stop me from getting there. I would like to thank my parents for their unconditional support in my education, Dr. Werman for all his help throughout these past 3 years, and Dr. Forsberg, because I would not be where I am today without her guidance. Thank you all for listening, and if you have any questions, please feel free to ask during the question session.
Thank you, Sophia. Next, we will hear from Tara Lowther. Tara has been investigating cardiovascular risk factors in transgender individuals with her mentor, Dr. Pooja Parikh from Stony Brook Medical Center.
Good evening. My name is Tara Lowther. I am a senior in the Hampton-based Science Research Program. For the past 4 years, I've been researching cardiology, specifically cardiovascular risk factors. In my freshman year, I began researching coronary artery disease because my father has it. Coronary artery disease is a disease in which plaque and cholesterol build up in the arteries, inhibiting blood flow. This research led me to realize that cardiology is intersectional. There are many different factors that play into your cardiovascular health, from your education status to your race, how old you are, and your gender. This presentation will be focusing specifically on gender. This chart shows HIV diagnoses among transgender individuals as reported by the CDC. As you can see, trans women are disproportionately affected by HIV. Further, Black and African American individuals were more likely to experience cardiovascular disease than any other ethnic or racial group. My mentor is Dr. Pooja Parikh. She's an assistant professor at Stony Brook Medical Center, and she's also the medical director of the Transcatheter Aortic Valve Replacement Program. I got to see her research live and in action at the Advancing Cardiology on the East End Symposium in 2019. While we have met in person, most of our research and mentorship has been through phone calls and video conferences. Dr. Parikh has been so supportive in guiding me through my research, helping me learn more about what it means to work in the medical field, and guiding me through the college admissions process. The first step in Dr. Parikh and I's research was collecting the data, which had already been done. The data was from a CDC survey from 2018, and it included data from transgender individuals and non-binary individuals. It included their gender, their age, their location, and it also included their medical history and how accessible care was for them. 14% of the participants in the study reported having cardiovascular disease, which might seem like a small number, but it is significant for only about 1,000 people. Race was not found to be significant in this study, but it has been found to be significant in other studies. Older people, less educated people, and veterans were more likely to have cardiovascular disease. I created this table based off of the data tables that I made from the CDC data, and as you can see, arthritis is significantly more frequent in individuals with cardiovascular disease as opposed to those without. This is also the case for depressive disorder. This is important to note because physicians need to be aware of the comorbidities that cardiovascular patients experience. This can help them to create a more individualized approach to care. My research was entered into the Long Island Science Congress and the Regeneron Science Talent Search. In the multivariate analysis, age was revealed to be a significant risk factor, which is common among all cohorts in cardiology. Financial barriers were more likely to be present in those with cardiovascular disease, which could mean that not being able to access or afford care increases an individual's likelihood for cardiovascular disease. Comorbidities, as we saw in the last slide, are associated with cardiovascular disease, which is another thing that physicians and politicians should be looking out for. Science research has provided me with so many opportunities that I would not have had otherwise. The first being speaking on the radio. I had the opportunity to go to Long Island MacArthur Airport and speak on Long Island News Radio. The second being clam seeding. Clam seeding is not something that I would have done or even known about if it weren't for science research. We worked with the Peconic Bay Rehabilitation Center to push clams back into the ocean to repopulate the clams in Peconic Bay. Our science research class participated in the Sparks Challenge at Peconic Bay Medical Center, and this gave us the opportunity to shadow doctors and learn from medical professionals, and it also made me realize that I do want to work in the hospital when I get older and starting now. So in my junior year, I worked in the emergency department of Peconic Bay Medical Center as an emergency department ambassador, and it was truly an opportunity that I wouldn't have known about if I had not been on the Spark Challenge. This is a picture of our senior science research class at Plum Island. I could not have asked for a better group of researchers to spend the past 4 years with. My plans for the near future include graduating from Hampton Bays High School and Suffolk County Community College with my associate degree in general liberal arts. I plan to attend a 4-year university where I will be practicing pre-med and studying biology. Thank you for listening.
Thank you, Shayna. Remember, if you have any questions for any of our speakers, either type their topic or type your question or their name in the comment feed, and we'll make sure that when we open it up for have all the students answer questions live, that we address your questions. I just said Shayna. I meant to say thank you, Tara. Shayna is our next speaker. Shayna will be presenting on radio frequency interference through radio astronomy. Shayna has been working on this for 4 years with her mentor, Ms. Justine Haupt from the Brookhaven National Lab.
Hi, my name is Shayna Pierce, and today I'll be giving my presentation on studying radio frequency interference through radio astronomy. And this is an image that I took at Brookhaven National Laboratory of their own radio telescope. So my research began my freshman year, where my topic was originally on environmental studies, but I quickly changed over my sophomore year to radio astronomy, since astronomy in general has been something that I've been interested in ever since I was a little kid. And I decided to investigate specifically on radio astronomy, since it isn't as well known, but radio telescopes are being used more significantly. And this is an image of a radio telescope on the right here. And you can see it's a lot different than what you're used to seeing telescopes as, which are optical telescopes. And radio telescopes are different from optical telescopes in that they use radio waves to capture their images instead of light. So radio telescopes can also be used at nighttime, since they don't rely on sunlight, and are also able to take images of invisible gases that you wouldn't be able to see with optical telescopes, also because it doesn't rely on light. As for my mentorship, I was able to obtain a mentorship with Miss Justine Haupt, and we met for the first time in this image on the left at Custer Observatory my sophomore year, September of 2018. And this is also us together on the right at Brookhaven National Laboratory performing an experiment together the summer of 2019. So for my internship at Brookhaven National Lab, I was lucky enough to do their high school research program, which is a 6-week summer program. I participated in person the summer of 2019 and virtually the summer of 2020. I wasn't able to be on campus the summer of 2020 due to COVID-19. But while I was on campus in person, I was able to gain many experiences. I learned the basics of Python coding computer language, and I was also able to perform an experiment with BMX, which stands for Baryon Mapping Experiment, their radio telescope on Brookhaven National Laboratory campus. So this image on the bottom is me at Brookhaven National Laboratory performing an experiment with an antenna and the radio telescope to see how the antenna was messing with the data and interfering with the data coming in through the radio telescope. And I was also lucky enough to be part of Brookhaven National Laboratory's High School Research Symposium the summer of 2019, and I was able to make a poster about the research that I did that summer. So as I said before, the summer of 2020 in the internship was a lot different compared to the first one. Due to the pandemic, I wasn't able to physically be on Brookhaven's property, so the research that I was able to do was very limited. So I mostly gained background in how radio telescopes worked, and I also created this graph, which is measuring flux density versus aperture. And flux density is basically measuring how strong a signal would need to be in order for the radio telescope to detect it. And aperture is the size of the radio telescope's dish. So as you can see, we use 4 different receiver densities, 1 times 10 to the negative 15th, negative 20th, negative 25th, and negative 30th watts per hertz. And I came up with an analogy to make this graph a little bit easier to read. So you try and think of it as if you're on a roller coaster. When you're at the bottom of a roller coaster and you're looking upwards, you can see everything above you, but when you're at the top, you aren't able to see anything below you. So this would be the same thing for the graph. So for example, this top line, 1 times 10 to the negative 15th, wouldn't be able to get any information from the Sun, Cassiopeia A, or Crab Nebula pulsar because the line is above it. But the bottom 2 lines, 1 times 10 to the negative 25th and negative 30th, would be able to get signals from all of these sources because the line is below. As for the research that I've been doing currently, as I said before, unfortunately, due to COVID-19, I lost access to be on Brookhaven National Laboratory's campus and access to their radio telescope. So my mentor decided if you lose access to a radio telescope, you have to build your own instead. So this is me and my mentor at Custer Observatory a few months ago, soldering together, building our own radio for an experiment. And this was a different path than I was originally planning to take, but I learned so much more about radios and how they actually work through this experiment. And as for my future plans, science research has helped me so much move forward and has helped me decide that I'm thinking about a science career in the future. It has insanely improved my public speaking skills and my time management, and has made me realize that I want to major in a science field, although I'm not sure exactly specifically which one. And that's my presentation. I'll be happy to take any questions that you have at the end. Thank you.
Thank you, Shayna. Our next presenter will be Dulce Pino. Dulce has been investigating components influencing cognitive reserve with her mentor, Dr. Sean Clouston from Stony Brook University.
Hi, my name is Dulce Pino, and today my presentation will be on components influencing cognitive reserve. First off, you have cognition, which controls our thoughts and behaviors. There are many different domains that make up cognition. For example, there is memorization, which is the process of how we memorize things. Reasoning, which is our ability to think of something in a logical way. Learning, which is how we acquire knowledge through either studying or experiences. Evaluating, which is how we comprehend information. And perception, how we recognize things using our senses. What is cognitive reserve? Cognitive reserve is the brain's ability to cope with brain damage by using pre-existing cognitive processes, and it's the efficient use of brain reserve when performing tasks. In this diagram, I will be using an example of an individual with Alzheimer's disease to further explain cognitive reserve. In this point over here, if the individual has cognitive reserve, they will not be presenting any physical symptoms of Alzheimer's while their brain is actively trying to deal with the brain damage caused by the disease. In this point over here, the brain can no longer deal with any more damage, therefore the individual will experience an accelerated decline of Alzheimer's, meaning that they will experience physical symptoms at a faster rate than normal. Going back to this point, if the individual does not have any cognitive reserve, they will be presenting symptoms at a normal rate. This point simply represents a point in time when they pass away due to the disease. There are many different factors that affect cognitive reserve. Today I organized a couple of them into two different categories, the first being education. Research has shown that the more years of education an individual has, the more cognitive reserve. Occupational attainment. Any type of job that individual has that requires a lot of analyzing, a lot of reading, a lot of writing, and simply keeping the brain active will increase cognitive reserve. And reading habits. As long as the individual is constantly reading, especially later in life, they will have higher levels of cognitive reserve than those who don't. My second category is lifestyle. Social and cultural activities are very important because this will allow the individuals to interact with people, learn new things, and experience new things, and constantly keeping the brain active, therefore increasing their cognitive reserve. My mentor is Dr. Sean Clouston. He is from Stony Brook University, and his research focus is on post-traumatic stress disorder, neuropathology, and more. We first met when I attended an Alzheimer's disease symposium in 2018, back when I was a sophomore. We were in contact for a couple of months, and then we decided to meet in January of 2019, where we officially established our mentorship. This picture was taken at the end of one of our meetings back in 2019. And this is our most recent picture of our Zoom meeting, where we discuss a few things like articles and data. Being in a science research program has taught me how to be able to speak with other people in a professional manner. I've learned how to manage my time, and I have definitely improved my public speaking skills, as well as how to be patient with myself. In this picture, I am with my two field hockey coaches who came and supported me in my first symposium. This picture here is my second and my last in-person symposium. I was a sophomore back in 2019. Future plans. I have currently been accepted to two colleges in their honors programs, the first being SUNY Oswego and the second Suffolk County Community College. I plan to major in cognitive sciences if I go to Oswego, or psychology if I go to Suffolk. I would like to thank Dr. Forsberg for her help and her support for the last couple of years. If it wasn't for her and this program, I probably would not have been able to go to college because I was very indecisive back then. So I would really like to thank her. So now I will be the first in my family to attend university. Thank you so much for attending our second virtual science research symposium. If you have any questions, please feel free to ask any questions.
Thank you, Dulce. Our next speaker will be Katarina Reich. Katarina has been investigating cochlear implants with adolescents with her mentor, Dr. Natalia Stupek from New York University.
Hello, my name is Katarina Reich, and tonight I will be discussing my science research topics in sophomore year, cochlear implants with adolescents. So a little background on cochlear implants. They have both an external and an internal component, and their main function is to bypass the damaged part of the inner ear, the cochlea. The cochlea is what allows people like you and me to hear, but will prevent someone from hearing entirely if it is too damaged. So here's how a cochlear implant works. Sound is played, and the sound travels from the processor to the receiver, and the receiver transforms the sound into electrical impulses. Electrical impulses are then sent to the electrodes in the cochlea. The electrodes were previously implanted inside of the damaged cochlea and almost act like a cochlea themselves. The electrodes send the electrical impulses to the auditory nerve, and the auditory nerve will interact with the brain, and the brain will recognize the electrical impulses as actual sound in a matter of milliseconds. This is groundbreaking technology when you think about how people who used to have a 10 to 15% capacity of hearing now are able to hear almost perfectly. So you might be wondering, well, what's the difference between a cochlear implant and a hearing aid? I'll discuss it in an analogy. So if you had a hearing aid and you were trying to listen to a radio station which wasn't coming in clearly, you would either fine-tune the radio station or raise the volume. Hearing aids are able to work because people with them have intact cochleas. So to hear better, all people have to do is amplify the sounds of what they're already able to hear to begin with. Compare that to someone who has a cochlear implant. If they tried to fine-tune their radio station by raising the volume, all they would hear is more static because their cochlea is not functional. They need a new radio to begin with, and the electrodes that are inserted into the cochlea act as that new radio. So that's the main difference between a hearing aid and a cochlear implant. Those with hearing aids have mild to moderate hearing loss. Those with cochlear implants have severe to profound. So my research question was, how are adolescents with cochlear implants forced to adapt to the world around them? And I was able to discuss this question with my mentor from NYU, Dr. Natalia Stupek. She works at the Electrical Auditory Research Lab, and the lab focuses on basic stimulations of the auditory nerve and specific cochlear implant frequencies. Below is an image of a virtual meeting her and I had in the past 2 weeks. So one of the best parts of working with Dr. Stupek was looking at previous research that she's done. The image on the left, all of those HZs are electrodes, and that curved figure is the cochlea. So the image is showing how the electrodes are actually placed in the cochlea, which is called an electrode array. The more electrodes that are inserted, the wider range of sounds someone would be able to hear. So a question I had was, what does it sound like to someone who doesn't have enough electrodes inside of their cochlea and then try to use a cochlear implant? Well, Dr. Stupek was able to show me this. So this is what normal speech sounds like to a normal ear.
The wife helped her husband.
This is what that same sound would sound like to someone who only has 12 electrodes in their cochlea.
The wife helped her husband.
It's really, really distorted. Here was the part that I really enjoyed because I really love music. She did the same thing, but with a song. So here's what the regular song sounds like.
I fell into a burning ring of fire. I went down.
And here's what the sound would sound like to someone who only has 12 electrodes.
I
so it's not enjoyable at all. This is why most people with cochlear implants have about 20 to 22 electrodes actually implanted into their cochlea. I really loved working on this with Dr. Stupak because I was able to see how this technology works, but also has its limitations. One of the other things I was able to do through the science research program was interview my cousin Sienna. My cousin Sienna actually uses cochlear implants. At 3 years old, she got the cochlear implant surgery. And ever since then, she's had a hearing capacity of 86% out of 100 compared to her 10% that she used to have. Through talking with Sienna, I learned about cochlear implants technology, but I also learned about how she lives with the cochlear implants. Circled in red is how the cochlear implant looks on her ear. She talked to me about how her teachers have microphones, and when they speak, what they're saying goes directly into Sienna's cochlear implants like Bluetooth. She also talked to me about how she's constantly learning. Right now, she's learning about how to discern background noise from noise that she's actually supposed to be listening to actively, which makes sense. I mean, imagine going from not being able to hear it all to suddenly being able to hear everything all at once. She's so incredibly strong, and I was so incredibly lucky to be able to interview her through the science research program. So my future plans, I'm graduating June of 2021 as salutatorian of the high school class. I'm pursuing a pre-med track in college, and I'm majoring in neuroscience. I hope to either become a neurosurgeon or a neuroscience researcher. And I was really able to amplify my love for science through the science research program. And I'm so grateful for the opportunities I've had and the opportunities that Dr. Forsberg has given me. Thank you so much.
Thank you, Katarina. Our final presentation tonight will be by Sarala Scully. Sarala has been investigating mental disorders and personality with her mentor, Dr. Kristen Gainey from the University of Western Australia, previously at the University at Buffalo.
Hi, my name is Sarala Scully, and I am researching mental disorders and personality with the help of my mentor, Dr. Kristen Gainey. When Dr. Gainey and I first connected, she was working at the University at Buffalo, so this was very convenient for me since my sister attends school there, and I was able to visit Dr. Gainey a few times and was even able to sit in on one of her classes about the treatment of anxiety disorders. However, about a year ago, Dr. Gainey moved to the University of Western Australia, so while we haven't been able to see each other in person, we have kept in contact through emails and occasional Zoom conferences. So moving into my topic a little bit more, in the beginning of freshman year when science research was just starting and we were starting to choose our topics, I saw some of my closest friends begin struggling with their own mental health. I didn't really know what to do or how to help them, and I thought that maybe if I start reading some articles and gaining a little more knowledge on psychology, I'll be able to be a better friend for them. So I did that, and I actually figured out that I really am interested in psychology and I really like it, and so I've stuck with it for the past 4 years. And this picture below just shows how common and significant mental health struggles are in the United States, especially for youth. If you see on the bottom in that orange box, it says that around 25% of Americans will develop a mental condition by the age of 14. And so knowing these facts and knowing how common mental disorders are has really motivated me to stick with this topic. I think it's very important that people are researching it, and it's a very prevalent issue around us. So yeah. So the first half of my focus has been personality, and personality is split into the big five, which is 5 domains, which each have 6 of their own facets, which are a little bit more specific traits of personality, and these are all listed below. And so the big 5 is broken into extroversion, agreeableness, conscientiousness, neuroticism, and openness. And I have focused a little more specifically on extroversion, conscientiousness, and neuroticism. And the next part of my research has been on mental disorders. So I have focused on internalizing disorders, which consists of one half of mental disorders and includes disorders like anxiety disorders, depressive disorders, OCD, and PTSD, which are more occurring in a person's thoughts and in their brain, rather than externalizing disorders, which includes disorders like ADD and substance use disorders, which manifest more in behaviors and actions. And this picture on the slide sort of just represents the differences between externalizing and internalizing disorders. The figure on the left shows the blue speaking out and acting out and represents externalizing disorders, whereas on the right, the internalizing disorder, the blue is just sort of stuck in its own mind, taking it all in. And so personality is actually highly related to internalizing disorders. A person's level of personality can help predict their risk for developing an internalizing disorder and can even in some cases help predict the severity of that internalizing disorder. And so, like I said on the last slide, I have focused on neuroticism, extroversion, and conscientiousness because they are the strongest predictors of internalizing disorders. And a combination of low conscientiousness, high neuroticism, and low extroversion can predict the greatest risk for any of the internalizing disorders. And so through my research, I have developed the specific question of how do the big five impact certain symptoms of depression and anxiety? And Dr. Gini has provided me access to a data set from one of her own studies, which I'm analyzing through SPSS to help me answer my research question. This data set contains information on around 300 participants who were all tested and interviewed to determine their levels for each of the big five, as well as for 13 symptoms of internalizing disorders. And so through my research, these are two scatter plots from the data set. These are two of many, but they are the most significant ones. And on the top left, this shows the relationship between neuroticism and anxious mood, which is a symptom of anxiety. And you can see by the red line the positive upward trends between the two. And so basically, as the level of neuroticism increases, so does the level of anxious mood. And while there are some outliers, this line shows a very strong correlation between the two and reinforces the idea, like I said, that neuroticism is a predictor for anxiety. And on the bottom right, you see the same trend represented by the red line, except this time the y-axis has dysphoria instead of anxious mood. And dysphoria is a symptom of depression that refers to a state of constant unease or dissatisfaction. And so both of these graphs show that neuroticism is strongly connected with depression and anxiety and is a strong indicator of depression and anxiety. And while I've greatly enjoyed all of my research and am so grateful for all of the opportunities that the science research program as well as my mentorship have provided me, I will not be going down a scientific path in the future. I plan to major in college in international relations, and while this may seem like a big jump from psychology, the program has actually really helped me realize what I want to do. So I came into science research knowing that I wanted to help people, and that is what my project has been focused on. But I've just realized that I don't want to continue doing so through psychology. Science research has also provided me skills like time management, professionalism, and public speaking skills, and I am so grateful for all of these. I will take these with me throughout college and the rest of my life. I want to thank Dr. Forsberg, who has been a mentor for all of us over the past 4 years, and especially this year has just been so there for us. Our class really has become a family, and I love all of you guys. And thank you so much for everybody watching tonight. I hope you enjoy the rest of the evening. Thank you.
Thank you, Sarala. We have enough time to have each of our presenters, each of our senior researchers answer a question from the audience. And then make sure you follow up in the comment thread. Our seniors will then follow up this evening and into the days ahead to answer any other questions that you may have. Our first question from the audience is for David Katina. David, this comes from your assistant principal, Dr. Greenberg. She first says, what an applicable topic that you have. And what do you think the future of 3D printing holds?
That's a really great question, Dr. Greenberg. And you're right, it's a very applicable topic. This is an area where many new scientific and technological Applications are being invented every day. And not only do I think that more prosthetic limbs will be printed, especially since they're cost effective and much more efficiently made time-wise, I soon think that fully 3D printed and functioning organs will be made, such as livers as well. Not really the heart yet, but livers are a real possibility in the near future of 3D printing.
Thank you, Dave. That's really pretty impressive work. And we're definitely going to be following up on that in the years to come. Our next question is for Sophia Lowther. Sophia, we're wondering, what do you think you will continue to work and research in college and beyond? Will you continue in this medical field or in any area in medicine?
Thank you so much for your question. Research has always been a tremendous passion of mine, and I do plan to continue it in college. I do not plan to continue my research on Huntington-Gilford-Paget syndrome or other laminopathies. However, I do plan to continue the field of science. There's nothing more compelling than science, and to me, the most intriguing area of science is neuroscience. Reading a lot about anthropology, it shows that brains become increasingly large and more sophisticated over time. However, brains have not evolved enough to win the war against neurodegenerative disorders. Through my own personal experience, when doctors diagnosed my grandma with Alzheimer's, there was no way to slow down the disease's progression. Witnessing this illness invigorated me to find treatments for others, which is why at Adelphi University, I hope to start researching neuroscience, specifically Alzheimer's disease.
Thank you. That's really interesting, Sophia. Well, we wish you all the best at Adelphi.
Thank you so much.
You're very welcome. Tara Lowther, we've got a question for you. Obviously, the news is filled with everything COVID related. We're wondering, have you spoken to your mentor since the pandemic about how any of her patients or patients that she's heard about, and are they at greater cardiovascular risk after having contracted COVID?
Thank you for your question. So COVID-19 is a disease that affects your respiratory system, which means that it increases the demand for oxygen, but your ability to attain oxygen is inhibited because of the disease. So this can lead to heart damage, but it's not certain what the long-term impacts of COVID-19 are because it's such a new form of SARS. But I'm looking into it, and I hope to learn more about it as COVID progresses and hopefully goes away soon. Thank you.
Thank you, Tara. I think we all can agree with that. Our next question is for Shayna. And Shayna, we're wondering from the audience, what did you enjoy most about working with your mentor at Brookhaven National Lab? And we know from the chat, she's actually watching tonight. So thank you so much for your time, Ms. Hopp. You've really gone above and beyond meeting with Shayna pre-pandemic, during the pandemics, safely, of course, at BNL. And we just really appreciate your time. But Shayna, tell us about it. What have you enjoyed most?
Thank you so much for the question. I think what I enjoyed most was just being able to perform an actual experiment with real equipment. I was just very grateful because that's not an opportunity that many people get to have, especially at 16 years old. So I was just really grateful to be able to use actual equipment with real data.
That's great. Well, again, we were very fortunate for that connection, and thanks to Ms. Hopp for making that available. Thank you, Shayna. Our next question is going to Dulce. Dulce, you mentioned that this program has brought you to not just apply to college, but to be accepted into 2 college honors programs. Do you think you might continue your research and your career possibly in psychology?
Hi, thank you for that question. It is definitely an option for me. I would love to continue it, especially if I do go to Oswego. If not, if I do go to Suffolk, I would find opportunities to go further into it because I will be majoring in psychology. Thank you.
That's exciting to hear that not only did you apply, get accepted, but now you will possibly even major in psychology. Congratulations. We're very proud of you, Dulce.
Thank you.
Welcome. Our next question goes to Katarina. Katarina, we have a question from the audience, and this, you'll definitely appreciate this question going with your connection and your love and passion for music. Does wearing cochlear implants affect how people hear music or their ability to hear a pitch?
Thank you so much for the question. Cochlear implants actually really do affect how you can hear music. My mentor, Dr. Stupak, actually did a couple of peer-reviewed articles about this. One thing that she found is that in general, people who use cochlear implants have a less emotional response to music. So they're not as moved, it sounds a lot more unpleasant. The sound sounds a lot more unnatural even. And people don't like music, to put it bluntly, as much as someone who hears normally might. And additionally, regarding pitch, people with cochlear implants can't hear pitch as well, can't discern what different pitches are supposed to sound like or what they're not supposed to sound like, compared to people who don't use cochlear implants. So there is actually a really big difference between how you can hear music with cochlear implants and how you hear music without. So thanks for the question.
That was a great question. I had a feeling that there would be some interest in the audience because we always know we're embracing our music and science connections. So thanks for answering that, Katarina. All right. So we've got a few more questions here, but we're going to go next to, I'm going to pause because we have a comment that came directly from one of the mentors, and Ms. Haupt from BNL said something for you, Shayna. She just wanted you to know that it's been really nice and she's enjoyed working with you as well. And she said that you even took to soldering like fish to water. So great job with your soldering skills. Not only we've got all sorts of life skills going on here. It's fantastic. We're really proud of you, Shayna. Thank you for that. All right. Our next, Sarah, we are going to finish our last question for tonight. And you actually have quite a few questions. So Sarah, I'm going to ask you to go back into the comment thread tonight and answer and follow up with some of these questions. But one of the topics I want to ask you is that you've been focusing on mental health. And how do you think that individuals and their mental health could have been changed during this time of the pandemic?
Thank you. Great question. I think it's definitely fair to say that everybody, no matter where you are or how old you are or what you do, has been impacted by Corona. Everyone has dealt with some type of loss. Everyone has gone through isolation, and all of these things have come with a lot of negativity and harmful impacts on mental health. So with that being said, it's really important to try to connect and keep in contact virtually with as many people as possible, which is one of the positives that has come out of the pandemic. There's been a lot more connection throughout the world, such as like we see tonight. And it's important to just keep up with self-care and mindfulness and things that can boost positive emotions in times of low.
I think you hit the nail on the head, Sarah. So many ways to look at the positive in all of this. And one of the positives we have tonight is just having this large crowd be able to watch us live. Thank you, Sarah. So you are definitely going to have to follow up in the chat because I saw another great question come in from another science teacher at Hampton Bays. Ms. Brando has an amazing question for you. Make sure you follow up on that. That's going to make sure everyone goes back into the comment thread tonight. We are going to end this evening with our principal, Mr. Richard, is going to end with a few closing remarks, and that will be our concluding our Science Research Symposium tonight. I will let Mr. Richard take over. Thank you all. Don't forget, next Thursday, or not next Thursday, 2 days from now, this Thursday, part 2. But Mr. Richard, go ahead, please. Thank you.
Thank you, Dr. Forsberg. I want to begin by congratulating all of our senior researchers on a job well done. You serve as an inspiration to students throughout the Hampton Bays community, and you make us more and more proud each and every day. I also want to thank Dr. Forsberg, the team at the University at Albany, and all of our professional research mentors. for providing you with a really unique learning experience and in many ways a graduate level study and an opportunity to contribute to the type of innovations that are going to change the world in the future. So great job, Hampton Bays, great job, Research and Science, and again, keep up the great work. We're looking forward to hearing how your contributions are going to impact all of your respective fields of study off in college. So again, we hope that everyone can join us next Thursday at 6 p.m. on the Hampton Bays Schools Facebook page live for the Underclassmen Symposium, where 16 researchers in grades 9 through 11 will present their research posters. Again, our senior researchers will be following up in the comment thread below, so please feel free to ask questions. We appreciate your participation this evening and look forward to seeing you on Thursday night. Thank you and have a great night.